Hello everyone, this is a project by Li Fang, Nepal Pranab and Davar Jamali. We are here to show you Rice Market ERP Enterprise Resource Platform, an AI-powered platform for rice traders and producers in Asia. So, rice prices are extremely sensitive to weather, uh, export policies, fuel costs, and global demands and other factors, which we are included in our modeling work. Large trading houses have analytics teams and expensive systems. However, small and mid-sized businesses usually have spreadsheets, PDFs, and gut feel. Our goal with Rice Market ERP is simple: help rice businesses get clear answers and forecasts from their data and documents using AI in seconds. So, what's Rice Market ERP does? Our Rice Market AI system has three main microservices. On the natural language SQL part, you can ask for example, in plain language, English language, you can ask, compare Thai and Vietnamese 5% broken rice prices for last quarter. On the document search part, you can search your own documents, upload market reports, policies, or contracts, and ask questions over them. On the price forecasting part, you can look ahead at the future rice prices with built-in forecasting models. All of this run on a cloud-native architecture with microservices, large language models, and time series forecasting models under the hood.
Thank you, Davar. As you said earlier, our UI comprises of dashboards showcasing our three capabilities. Natural language to SQL converter, which enables user to use English to query the database. Document drag, which is used to keep document and context relevant to the user. And finally, forecasting that predicts demand and prices. Our system uses a modular cloud native architecture built around microservices, multi-agent intelligence, and integrated data and machine learning pipelines. All inquiries from user are passed through GK Ingress and are validated through authentication middleware. And this connects with backend GKE using HTTP protocol. The agent coordinator that acts as a brain of our system uh, decides which uh, decides which agent is appropriate for the given use case. The request is then handled by microservices and flows through our machine learning pipelines that handles data preparation, training time series model, and model versioning with DBC. The data and the results are then stored on Postgres and Airtables, which is displayed back to the dashboard using our front-end services.
These dashboards serve as the unified entry point to distributed microservices architecture running on Google's Kubernetes engines with four concatenalized services, communicate via Kubernetes service DNS resolutions via box 8001, 2, and 3, and all orchestrated by an agent coordinator export 8000. The market overviews matrix fetched from real time from Cloud SQL's Postgres SQL instance. The system implements an A2A protocols, agent to agent for service discovery. All services deploy via Pulumi infrastructure at cost with a horizontal post autoscaler configured as a 70% CPU threshold, scaling from 1 to 5 replicas. The CI/CD pipelines on GitHub Actions enforce a 95% test coverage with the ML training pipeline triggering Vertex AI custom jobs. For the natural language query in SQL only most, the query routes directly to POX and supports 8001 by passing the agent coordinators. The green online status indicates successful health endpoint response from the Kubernetes load balancers. The request invokes the fine-tuning Gemini's 2.0 Flash endpoint, trained via Vertex AI supervised fine-tunings with LoRa adapter, Site 4 on 81 domain-specific examples. Results executes against Cloud SQL, PostgreSQL with connection pools. In the multi-Asian malls, we will engage Asian coordinator service with implements A2A protocol for dynamics Asian orchestrations. In the document shift racks page SPOX 8002, we implement agentic graph racks with hybrid retrievals. The knowledge-based sources show two retrieval paths, company database, and document loading supporting PDF, doc, and plain text. Chunks as content as 1,000 character with 200 character overlap for context preservations. The embeddings generated via OpenAI text embedding 3 smalls, 1,536 dimensions. Retrievals use cosine similarity rankings, returning top K results. In the right price forecasting page, for the short-term 3 months, the system will select ARIMA with Excel as short-term horizon due to auto-regressive flags fitting recent price movement. For the medium terms and long terms, system will switch to Morae's time series foundation model with zero-shot forecasting capabilities, leverages retrain weights on diverse temporal datasets, eliminating domain-specific training requirements. That's it for our group. Thank you for watching.